In this video we're going to look at a way of combining functions to form composite functions. So we're going to start off with a simple example. So we've got a function f of x with the domain 1, 2, 3 and 4. Okay, the rule for f of x is 2 times x plus 1. Nice easy one. So 2 times 1 plus 1 is 3, 2 times 2 plus 1 is 5, 2 times 3 plus 1 is 7, 9. Okay, so here we have the domain of f, and here we have the range of f. So now I'm going to introduce a second function, g of x, and I've chosen 4 minus 3x for that. And we're going to make the range of f into the domain of g. So we're going to map these outputs using another function, g of x. So we're going to have, first of all, 4 take away 3 lots of 3, so 4 minus 9 is minus 5. Then 4 take away 3 lots of 5, 4 minus 15 is minus 11. And then we get minus 17 and minus 23. So here we have the range g of x on that domain of 3, 5, 7, 9. We could also describe this as a single function where we go from, well, a composite function. I wouldn't say a single function, but we can get a single rule that will take us from the domain of f onto the range of g. And the notation, the way of writing that would be to say g of f of x. So that what that means is you put f of x into g. You might be able to spot the rule going directly from the domain of f onto the range of g of f of x. But I'm going to show you how to do it on the next slide anyway, but just for an intellectual practice, just see if you can do that. Okay. So if we combine our two functions to find the result g of f of x, what we're actually doing there is we're putting the result of f of x, which is 2x plus 1, as the input into g of x. And g tells us to do 4 minus 3 lots of the input. Okay, so we've got 4 minus 6x minus 3, or 1 minus 6x. Possibly you spotted that rule on the previous page. So is f of g of x the same? Let's see. So this time we're going to put the result of g of x, 4 minus 3x, into the function f. So we're having f of 4 minus 3x. So f tells us to do 2 times the input, and then add on 1. So here we have 8 minus 6x plus 1. So now we've got 9 minus 6x. So no, they're not the same. Okay, we can also find specific values. So let's do one we've already done. So if we want to find, say, g of f of 2, that means we're going to put the result of f of 2, so that's 2 times 2 plus 1, into g. So we're going to have 4 minus 3 lots of 5, which is minus 11. Agrees with what we had on the previous slide. Not one we haven't done before. If we wanted f of g of 2, say, then that time we're going to put, we know it's a different result because we've got a different general result, so we're going to put the result of g of 2, so that's 4 minus 6 minus 2, into f, which will be 2 lots of minus 2 plus 1, which gives us minus 3. Okay. So now I've got 3 new functions, f, g and h, and we're going to combine those in different ways to find these results. So let's start off with the first one. So we want to find f of 2. Okay, so for that we're going to find f of 2. So that's going to be 2 squared. So we're going to find f of 4, which is 4 squared, so that's 16. Second one, if we want a general result for that, so we want f of x, we're going to find f of x, which is x squared. So we're going to then square x squared, so we'll get x to the power of 4. Okay, next one, we're going to combine 3 functions now. Whoops, let's see. So we want
f of g of h of 1. Always start with the function closest to the number, so we're just going to write the f and g down, and we're going to find h of 1. So that's going to be 3 times 1 minus 1, looking at the definition of h above. So that's going to give us f of g of 2. So then we're going to leave the f as it is, and we're going to find out what g of 2 is. So g of 2 is going to be 1 over 2. And then we're going to apply f to that output of a half. And so we've got a half squared. So the final answer is a quarter. So for a general result of, lost my step there for a second. F of g of h of x. We'll do the same process, but this time in a general way. So we're first going to have f of g of h of x, which is 3x minus 1. We're then going to apply g to that result, which is 1 over 3x minus 1. And then we're going to do f, which is square it. So we're going to have 1 over 3x minus 1, and that's all squared. So now we're going to take the functions in a different order. So we're going to have g of f of h of x. So we're starting with h again, but we're going to have g of f of the result, 3x minus 1. Then we're going to apply f to that, so we're going to have 3x minus 1 squared, and we're going to apply g to that, so we're going to have 1 over 3x minus 1 squared. You might notice that those two results are in fact the same. But let's just see the last one. So now we've got a third order, so we've got h of g of x. So this time we're going to first find out what f of x is, which is x squared. We're then going to apply g to that, so we've got 1 over x squared. And lastly we're going to apply h, which is to do 3 times 1 over x squared. So I've missed my equal signs for there for some reason. And then subtract 1. So we've got 3 over x squared minus 1. And this time it's a different result to the other two. So they're not always the same.